are starting. Back. Final day. Lesson 3.5. We're on the back. Finding real and complex zeros. We're ready for example C. Okay? So, as you look at the graph, what does the graph tell you about zeros?
There's one at -4.
What?
Wait, am I wrong?
There's two.
There's two.
-2 and 2. -2 and 2.
-2 and 2.
Oh yeah.
Because zeros can be found any place my graph crosses the
X-axis.
x-axis. So, I know right now there are zeros at x equals 2 and -2. Now, if there are zeros at x equals 2 and -2, what factors do those represent?
2. They're -2 and 2. Next.
So x minus 2 and x plus 2, right?
Yeah.
So if you're ever asked to write it out in factored form, we know those two factors for sure. Now, with that in mind, it's asking us to find all the real and complex zeros. We know the real. Because this is x to the 4th, how many total zeros am I going to have? If I made that tie in here, I think I have. Since it's x to the 4th, we're going to have 4 total zeros. I only have 2 right now. The other 2 are going to be complex or imaginary. And we're going to use our synthetic division to get there. So, start with one of these. And let's see, I'm trying to remember. We've only ever had one real zero given to us, haven't we? So this one I get to demonstrate, okay, what do we do when you have 2 real zeros given to you? So pick one to start with, and let's do our synthetic division. Okay? If I put 2 in the box, what's the row of numbers beside it?
Oh, Lord.
1.
Yeah.
1,
-3, 0.
Zero.
-3,
-3. No. Oh. 0, x, 1, 0, -3, 0, -4.
Okay. So teamwork, I think we have it all figured out. Why some zeros in there? There's missing place values, right? If it starts with x to the 4th, that's a 1. After x to the 4th should come x to the 3rd. There isn't one, so I'm going to put 0. Then x squared is -3. After an x squared should be an
X.
x.
Yeah.
So 0, and then -4. Okay. Remember our synthetic division?
Yep.
Yes, ma'am.
Bring the 1
Yes,
down.
ma'am.
Multiply 2 by 1, you get 2. Add those, you get 2. 2
Okay.
times 2.
Hold on, let me catch up. Bring 1 down. 2 times 1 is
You are beat, huh?
2. 0 plus 2 is 2. 2 times 2? 4. -3 plus 4. 1. 2 times 1? 2. 0 plus 2?
2.
2. 2 times 2?
4.
4. -4 plus 4?
0.
0. Okay, guys. Right here, that tells me there's a remainder of 0, which is what we want to see, right?
1, 2, 1, 2.
And that means that 2 works as we expect it to work, right?
Yep.
Now, we have another value to check. And so we could do this a couple different ways, but my recommendation with the -2, rather than go back into your original set of numbers, we're going to factor this down and now use our new set of numbers instead. And let's see, do I have room to do this right below? I don't know if I do or not.
Why not?
I mean, it's, you know, a chunk of my favorite lessons.
So if I put -2 in the box, instead of my original line of numbers, we're going to use this new set,
1, 2, 1, 2.
the 1, 2, 1, 2. This is our factored, we're factoring this down is what's happening.
Oh.
So 1, 2, 1, 2, and do our synthetic division.
Bring your 1
Now.
down, so not the 0. -2, 0,
Yeah, we didn't need the 0 because that's a remainder.
Oh, by golly, look at that.
Okay, so bring the 1 down. -2 times 1 is -2.
-2.
2 plus -2,
You got a big fat
0. -2 times 0,
0.
0. 1 plus 0,
1.
1. -2 times 1,
-2.
-2. 2 plus -2.
Well, look at that.
101.
Okay. Now,
It's all late. Well, that's remainders, so you don't count.
okay, so remainder 0, which we should get. What does this 1, 0, 1 represent?
101 is 101.
When we put the x's back in.
Ah, you're right.
Oh, X
This be X.
3.
Oh, no.
Uh,
X
I don't know.
Right here. X squared, X, nothing. Was that right? Because you bring it from the.
Way to dog
So it'd
me.
be so in the when you did divided by 2, when you did divided by 2, your answer would be like that one right there.
Well, he's on
So that'd be X4. So that'd be X3.
Hold on a dog.
And then when you brought that over, you would subtract one of the exponents, would be X2.
Okay, so are you following what he said there?
Happy day.
We started with the problem x to the 4th. My first answer was x to the 3rd. So now that we're using x to the 3rd, 1 below x to the 3rd is going to be x squared. Now, so this represents 1x squared plus the 0 is 0x,
X.
which I don't really need to write. And then the 1 is a
Hold on.
plus 1.
Whoa.
Okay. So we're going to write our factors out now. So the 2 at first represents the factor x minus 2. The -2 represented the factor x plus 2. What's the factor I just came up with? X squared plus 1. And I'm setting it up this way because we need to have all 4 zeros. How do we find zeros officially here? Take each of these pieces and
0.
set them equal to 0. As I said, we already know the first two. We already know x minus 2 equals 0 is going to give me
X plus 2.
X equals 2. X plus 2 equals 0 is going to give me
X equals negative.
x equals -2. What about x squared plus 1 equals 0?
Okay. X squared.
How do we solve for x?
Subtract 1.
Okay, so if it's x squared plus 1, subtract 1. X squared equals -1.
Can't you divide or you square root?
Then officially we would take the square root.
Can't
What's the square root of x squared? X.
equals I. Negative I or just I?
Just
It's I.
What happens when we take the square root in an equation setting?
Plus minus. Oh, that's a good one.
Plus or minus I. So yes, I agree, the square root of -1 is I. Because we're in an equation setting, the square root of we're going to say plus or minus I. Now, do we have 4 zeros here? 2,
Yes.
-2, I, and -I. And it makes sense, 2 of them are visible on the graph. The other 2 are imaginary. They're complex zeros. Okay? These are my real 2. These are my complex 2. Yes, Aaron?
Give this tape.
Yes, Landon?
They're imaginary. Why do we even have to do that?
Great point.
Because it asked me to find all, how did it say? Real and complex zeros.
Well, we need to tell them that there
They
are
should-
2 fake ones.
I shouldn't have asked.
Okay.
It's kind of personal information.
Okay, guys, so this is a review of what we did on Friday, right?
Yes.
We did the two above it on Friday, so if you weren't here, make sure you get those notes. But that kind of reviews it with you. We've got one bottom section to work with. And this is asking for the solution of the equations.
Is this one easy?
As we look at these two, this is more based on technically stuff you already know. Solving the equation, and we're going to check a few factoring skills. Okay. I'm trying to remember, there's another factoring skill I had on my brain Friday I need to talk about. I'll have to look back and see if I remember what it was. But if you have this big messy equation on A, what are you probably going to start doing?
I don't know.
Yes.
Combine like terms.
Okay. So as we look to combine like terms and put like terms together in the process, make the equation equal to 0. Let's try it. Now, as we start to combine like terms,
So we put time.
let's see. Notice what happens when I go to move an x cubed. If I subtract x cubed from either side, they're going to be gone.
Oh, that's genius.
I'm going to notice that I have a positive 5x squared on the right and no other x squareds. So if you guys can handle it, I'm going to move everything to the right.
Whoa.
No?
Yes.
Why would you just rewrite it?
Well, here's the if I move everything to the right, I'm keeping my positive 5x squared. I'm not making it negative. That's my reasoning. Okay? And officially, I have one less term to move. Okay? So, in order to move a minus 7x,
You add 7.
add 7x, add it to the like term on the other side. In order to move a plus 6, subtract 6. So on the left, everything will cancel. 0 equals 5x squared
Plus 5.
plus 5x
Minus 30.
minus 30.
Well, I'll be done.
Now, if you didn't already put 0 equals out front, you can put equals 0 out back.
Out back.
What do you notice about all three terms? Oh, do they all have a factor of 5 in them?
Yeah.
All right.
Now, in an equation setting, I'm actually going to factor the 5 out. But because it's an equation and equals 0, you could also just divide the 5 out. And I'm going to flip-flop my sides as I go here.
Whoa.
If I factor a 5 out, 5x squared divided by 5 is
5x. Or it's just x.
x squared
Right.
plus 5x divided by 5 is x minus 30 divided by 5 minus 6 equals 0. This problem just became a lot easier.
I think I'm ready.
Now, some of you may be saying it did, which is fine.
Right.
Focus inside the parentheses. X squared plus x minus 6. And it equals 0. If I'm trying to solve this,
Wow.
I'm going to cross my fingers and hope that it can factor. What factoring method are we going to try right now?
The parentheses one, where you drop her down.
X squared goes into 2 parentheses.
2 parentheses?
Yeah.
This is what I call product and sum.
Oh, PAC. No, that's PAC.
Now, this 5, I'm just going to leave out front. Because this is already a 1x squared, I can just do product and sum. If there was a number in front of the x squared attached to it still, I'd have to do product of AC. X squared breaks into x and x.
You need a -2 and a +3.
Negative 2, positive 3. Does that make sense?
He's right.
He's right.
Negative 2, positive 3, because we need a product of negative 6 and a sum of 1. So 2 and 3 will accomplish that if the 2 is negative.
That's my answer.
Okay.
Are we done?
Have I found a solution?
I reckon.
No, I'm not done.
Now what I wanted to hear.
We're almost done.
It's x plus 2 and x negative 3.
What about a 5?
Those are the solutions. And a 5. You just throw the 5 on top.
Not quite. Almost. Okay, so officially we're going to set each part equal to 0, right?
Yep.
The main two pieces are x minus 2 equals 0 and x plus 3 equals 0.
Yep.
If this 5 had an x with it, it would be important.
Yeah.
But if I just take 5 and set it equal to 0, there's no variable there, is there?
No.
5 doesn't equal 0. You don't have to worry about a constant. You only have to worry about the factors that involve x's. Okay? So, add 2. You're going to tell me x equals 2. Subtract 3. You're going to tell me x equals negative 3. We have solutions of 2 and negative 3.
You want 5 on top, so you can.
Actually, I said this was.
That was a big, ugly looking problem, if you ask me. However, it really broke down into skills we know already, right? Okay. Okay. Ready to look at B?
Nope.
Yeah.
Already did.
Start with the same process as last time.
Stop. Bring it down.
Yes.
Add the x cubed and add the 2x.
So we're trying to make everything equal to 0. We're going to add x cubed. We're going to add 2x. What happens when we add those over?
Yeah.
They just get added to the equation.
Okay. They don't have like terms they can add with, do they? Now, do me a favor. Put them in standard form order. Highest power to lowest power. Okay. So that means I'm going to have x to the 4th plus x cubed plus 2x squared plus 2x equals 0. Okay. So this one's a little different. We've got 4 terms here to work with. Okay. So we'll talk about a method here in a moment. But factoring that works for any amount of terms. What do you notice about all these terms? They all have an x, don't they? Okay, so there's a GCF of x we're going to factor out. Now, you have to put this x out front. If you're someone and last time you divided the 5 away, that was fine. The 5 didn't matter. But an x matters. So we're going to factor out GCF of x. X to the 4th divided by x. X cubed. Plus x cubed divided by x.
Square.
X squared. Plus 2x squared divided by x.
What's that?
2x. Plus 2x divided by x. 2. Still equals 0. Now, that x out front carries down no matter what. Do not lose it because that represents an answer. If you lose it, you've lost an answer. Now, inside those parentheses, we have 4 terms. And we've done a little bit of this, but I don't know how much we've done it exclusively for just this piece. How do we factor 4 terms?
No, give up.
How do we factor them? This is where, okay, we're not talking product and sum. We're not talking product of AC. However, this
Quadratic
method is
formula?
used within product of AC. Can't do a quadratic formula because it's x to the 3rd, not x to the 2nd.
I don't know that.
Okay. We've got 4 terms. Take your 4 terms, split it in half. Okay, and I'm just looking, you realize I'm just looking at this piece is right here, right? That X out front, irrelevant. Take your 4 terms, split them in half.
Oh,
We do this in product of AC, don't we? It's called factoring by grouping. We just haven't done it on its own a whole lot, but it's a skill you need to know. And this is actually a skill, had I taught it differently, where did I think I could use this the other day? I feel like we could have used factoring by grouping. I don't know, maybe it just comes up in the homework. Maybe that's what it was. Okay. So, what is the GCF of these first two? X cubed and x squared. What do they both divide by?
X
Square.
squared.
Go big, right?
That's
Go big or go home.
That's what I'm.
Big or go home. So x squared is the highest power they both have in common. So we're going to factor out an x squared. X cubed divided by x squared is x. Plus x squared divided by x squared is 1. Okay. Now it's the second half. What do 2x plus 2 have in common?
2.
A 2? Is that a positive 2 or negative 2?
Positive.
So I'm going to write a plus 2 here. And I'm going to factor out a 2. 2x2 divided by 2, or 2x divided by 2. X plus 2 divided by 2. Excuse me, 1. Okay, guys.
Yes.
Good news.
Yes.
Why do I know I'm on the right track?
Because you're thinking of it.
Because you got, yeah.
X plus 1's matter. Excuse me. Okay, what do I still need to have out front? X. What's one of my factors? X plus 1 was matching, yes? So since x plus 1 is matching, x plus 1 is one of my factors. When I pull that x plus 1 out, what are the remaining pieces?
X squared and 2.
X squared plus 2. Almost there. Officially, to find our zeros, we set each part equal to 0, including the x. I didn't care about the 5 earlier. It was a number, not a variable. I care about the x. So I'm going to have x equals 0, x plus 1 equals 0, and x squared plus 2 equals 0. Well, I got x equals 0. If it's x plus 1, we got x equals negative 1. What about that x squared plus 2? Subtract 2. X squared equals negative 2. Take the square root. What's the square root of negative 2?
Plus
Okay, so I heard the plus or minus. Good. I heard all the pieces. It's just putting them all together in an equation saying taking the square root, plus or minus. Square root of a negative means we pull that negative out as an I. Can we do the square root of 2? No, so we're going to leave it.
Yes, ma'am.
How many answers do I have on this problem?
3,
4.
1, 2, 3, 4. How many answers should I have? 4, because it was an x to the 4th is the highest problem. Okay, guys. Your homework, if you haven't already started it, is lesson 3.5 in Savas. I did change the due date, so it should be showing as due tomorrow.